Pluto, a far-flung and enigmatic world, was once a solitary and reliable planet within our solar system. However, recent discussions among leading astrophysicists, including Neil deGrasse Tyson and Michio Kaku, have thrust Pluto back into the limelight with surprising revelations. These scientists have proposed that Pluto's orbit may eventually intersect with Neptune's, a notion that raises questions about how such a collision might occur and what the consequences of such a cosmic event could be. Could this lead to a 32 seconds fascinating and unusual anomaly, or is there something more to this potential planetary collision? Join us as we delve into the possible outcomes of a Pluto-Neptune impact. Pluto, once considered a planet in its own right, is now relegated to a smaller category thanks to its unusual orbit and its status as a dwarf planet. Despite its demotion, Pluto remains a subject of fascination and research within the scientific community. Recent studies by leading astronomers show that Pluto's orbit is perilously close to Neptune's, raising alarms among 1 minute and 7 seconds astrophysicists like Tyson and Kaku about the possibility of a catastrophic collision between the two. But how could such a collision happen? Unlike the other planets in our solar system, Pluto follows an eccentric path around the Sun, taking an astonishing 248 years to complete one full orbit. Since its discovery in 1930, Pluto has not even finished a single orbit around the Sun. However, the intrigue surrounding Pluto does not end there. Its orbit is characterized by a highly elliptical shape, unlike the nearly circular orbits. 1 minute and 41 seconds of the larger planets. What makes Pluto's orbit even more perplexing is its tilt. Pluto's orbit is tilted at an angle of 17 degrees to the plane of the solar system, which adds complexity to its orbital dynamics. This tilt, combined with its irregular shape, makes Pluto's orbit significantly more chaotic compared to the other planets. One of the most interesting aspects of Pluto's orbit is its interaction with Neptune's. For approximately 20 years of each orbit, Pluto actually comes closer to the Sun than Neptune, which is contrary to what 2 minutes and 16 seconds one might expect based on their positions within the solar system. This raises the natural question: why hasn't Pluto collided with Neptune? The answer lies in the gravitational influences of other planets in the solar system. When Pluto's orbit was first studied after its discovery, astronomers struggled to understand its unusual trajectory. Unlike the orbits of other planets, which lie close to the ecliptic plane, Pluto's orbit stands out due to its steep tilt and elliptical shape. The mystery surrounding Pluto's orbit only deepened. 2 minutes and 48 seconds when it was found that, in the grand scheme of things, Pluto's orbit does indeed cross that of Neptune's. This apparent paradox is resolved by the complex gravitational dynamics of the solar system, specifically through a phenomenon known as the three-body problem. The three-body problem in astrophysics is the challenge of predicting the motion of three objects, like Pluto, Neptune, and the Sun, that influence each other through their gravitational forces. The interactions between these objects create a dynamic 3 minutes and 19-second system that is difficult to predict, as each body affects the others in a constantly changing way. For Pluto, this three-body problem helps explain why its orbit is stable despite crossing Neptune's orbit. One key concept that keeps Pluto's orbit stable is libration. In the case of Pluto and Neptune, this term refers to the phenomenon where, whenever Pluto crosses Neptune's orbit, the two planets are always at least 90 degrees apart. This spatial separation is crucial in preventing the two bodies from colliding. Another important factor is degree. 3 minutes and 52 seconds libration ***, which refers to the vertical movement of a celestial body within its orbit. For Pluto, this means that when it comes close to Neptune or any other large planet, it remains situated well above or below the plane of their orbits, adding another layer of protection against potential collisions. A third concept that stabilizes Pluto's orbit is VZK wobbling, named after the three scientists, Vladimir, Zharkov, and Krivov, who studied how celestial bodies move in space. This phenomenon refers to the way in which Pluto, Neptune, and the Sun influence each 4 minutes and 26 seconds other through gravity, causing slight shifts in their positions over time. In Pluto's case, VZK wobbling helps explain why its orbit, despite seeming erratic, remains stable. These forces contribute to maintaining Pluto's orbit for incredibly long periods, possibly even billions of years. Although Pluto's orbit is chaotic in nature, these gravitational influences from other planets help keep its trajectory stable. In the broader context of the solar system, these forces play a vital role in preventing planets 4 minutes and 58 seconds, and other celestial bodies from crashing into one another. Without these stabilizing factors, the solar system would be a much more tumultuous place, with planets and dwarf planets potentially colliding or being ejected from their orbits, causing a cascading series of impacts. For Pluto, this is especially important given the ongoing discussions about a potential collision with Neptune. Understanding Pluto's orbit gives us insight into the dynamic nature of the solar system. It serves as a reminder that even the most seemingly 5 minutes and 29 seconds unstable orbits can achieve a state of equilibrium through the intricate dance of gravitational forces and orbital mechanics. The study of Pluto's orbit also highlights the need for continual research and observation to better understand the forces that shape our solar system. The case of Pluto illustrates the importance of studying the unpredictable nature of celestial bodies and the role that gravitational interactions play in their movements. The future of Pluto's orbit, a cosmic balancing act. Despite the numerous gravitational forces that keep Pluto's orbit stable, astrophysicists like Tyson and Kuiper continue to raise important questions. Could an external force, such as a passing star, a rogue planet, or even subtle shifts in the Sun's mass, eventually disturb Pluto's delicate balance? While current models suggest Pluto will remain in its stable resonance with Neptune for billions of years, the future is never entirely predictable. One of the key reasons scientists remain cautious is the sensitivity of orbital mechanics. A tiny shift, perhaps caused by an unknown object from the Oort cloud, could nudge Pluto's orbit just enough to break its protective resonance with Neptune. If such a disruption were to occur, the consequences could be profound. In the most extreme scenario, Pluto could be sent into a chaotic trajectory, potentially. 1. Colliding with Neptune, an event that would forever reshape the outer solar system. 2. Being ejected from the solar system, becoming an interstellar wanderer lost to the depths of space. 3. Entering a new orbit, possibly moving closer to the Sun and undergoing dramatic atmospheric changes. 17 minutes and 22 seconds. The role of the Kuiper belt. Another factor that could influence Pluto's fate is the Kuiper belt, the vast region of icy bodies beyond Neptune. Pluto is one of the largest known objects in this region, but it is not alone. Thousands of other icy worlds, some potentially the size of Pluto, share its space. As these Kuiper belt objects, KBOs, interact over time, collisions or gravitational tugs could subtly alter Pluto's orbit. While minor shifts may not be immediately catastrophic, over millions of years, these small changes could accumulate into something significant. Astronomers continue to study whether a hidden planet 9, theorized to exist beyond Neptune, might exert a gravitational pull on Pluto and other KBOs. If such a planet exists, its presence could have unexpected consequences for Pluto's long-term stability. 17 minutes and 59 seconds. What if Pluto did collide with Neptune? While the odds of a direct collision between Pluto and Neptune are low, it's worth considering what might happen if the unthinkable occurred. Immediate aftermath. A Pluto-Neptune impact would be a catastrophic event, likely vaporizing Pluto upon contact. The immense energy released could generate massive shockwaves through Neptune's atmosphere, potentially altering its cloud structures and internal dynamics. Debris field. The collision would scatter debris across the outer solar system, creating a new ring system around Neptune or forming a new family of small moons. Effects on other planets. The gravitational effects of such an impact could ripple outward, subtly altering the orbits of other celestial bodies, including Uranus and Saturn. Some astronomers speculate that such events may have already occurred in the solar system's past. Could Pluto itself be a remnant of a long-lost planetary collision? 18 minutes and 40 seconds. The ever-changing solar system. Regardless of whether a Pluto-Neptune collision ever takes place, one thing is certain: the solar system is an ever-evolving system, shaped by countless gravitational interactions. Understanding Pluto's orbit is not just about studying a distant dwarf planet, it's about grasping the fundamental forces that govern the universe. The more we learn, the more we realize how delicate the balance of our solar system truly is. As we continue to explore the mysteries of Pluto, Neptune, and beyond, we are reminded that space is never static. It is a dynamic, living system, constantly changing, always full of surprises. Who knows what the future holds for Pluto? Perhaps one day, we will witness an unexpected shift, one that reshapes everything we thought we knew about the solar system. The unseen forces at play. While Pluto's current orbit appears stable, astrophysicists remain vigilant. The vastness of space hides unseen forces, subtle gravitational nudges from passing objects, dark matter's elusive influence, and even the lingering effects of ancient cosmic events. Could an undiscovered factor already be setting Pluto on an unpredictable course? One theory gaining traction among planetary scientists suggests that the Sun's gradual mass loss, as it burns through its nuclear fuel, could cause minute but significant shifts in the orbits of planets and dwarf planets alike. Over billions of years, even a fraction of a % decrease in the Sun's gravitational pull could alter Pluto's delicate dance with Neptune. 19 minutes and 12 seconds. A galactic encounter. Beyond the solar system, the Milky Way itself is in constant motion. Every few million years, rogue stars from the galactic disk drift perilously close to our Sun's neighborhood. These stellar visitors could perturb the Oort cloud, sending a barrage of comets toward the inner solar system, or, perhaps, subtly disrupting Pluto's orbit. Could a distant star's gravitational tug be the event that finally breaks Pluto's resonance with Neptune? If so, what would happen next? 1. A close brush with Neptune. If Pluto's orbit shifts just slightly, it could experience a near miss with Neptune in a future pass. This close encounter might slingshot Pluto into an even more eccentric orbit, perhaps bringing it closer to Uranus, or even toward Saturn. 2. An ejection from the solar system. If the disruption is severe, Pluto could be cast out entirely, becoming a lonely wanderer between the stars, a frozen relic of our solar system's past, doomed to drift endlessly in interstellar space. 3. A collision with another Kuiper belt object. A change in Pluto's orbit could bring it into an unexpected meeting with another Kuiper belt object, KBO, triggering a cosmic impact that would send debris scattering across the solar system. 19 minutes and 58 seconds. A sudden shift in Pluto's fate. What if Pluto's orbit is already changing in ways we can't yet detect? With recent advancements in gravitational wave detection and deep space observatories, scientists are beginning to uncover subtle shifts in planetary movements that were previously invisible. In a groundbreaking study, a team of researchers at the James Webb Space Telescope detected an anomaly in Pluto's trajectory, something unexpected, something that hints at a slow but definite deviation from its predicted path. Could this be the first sign of a future collision course? Or is it evidence of an unknown gravitational force, a disturbance lurking in the outer reaches of our solar system? If Pluto is on the edge of a cosmic shift, the implications could be profound. Would humanity witness the moment when a planet, once part of our solar system's intricate balance, was cast out into the darkness? 20 minutes and 37 seconds. The cosmic unknown. As scientists race to refine their models and track Pluto's future movements, one truth remains clear. Space is far less predictable than we once believed. The solar system is not a static, clockwork mechanism. It is a living, evolving system, shaped by the delicate interplay of countless gravitational forces. Perhaps Pluto's fate has already been sealed, written in the unseen forces that govern the cosmos. Or maybe, just maybe, there is still a mystery waiting to be uncovered, one that could change our understanding of planetary dynamics forever. And so, Pluto continues its long, lonely journey through space, an enigma among the stars, carrying with it the secrets of an ever-changing universe.